this is John. This field here shows how when you till a soil, when it's very dry, you create these very dense and hard clods. That's simply because the drier the soil is, the harder it becomes. And especially when you have very poor organic matter and very poor structure, when it becomes dry and you till, you end up with these very hard and large clods. And these clods now, to break them up, you need to either put a roller over the top or a disc, and so you further pulverize the soil and further create problems for you in the future. So someone made the comment that tillage is anything that causes long-term damage to your soil. And to be honest, this is what I think we are seeing here. This tillage is causing long-term damage to the soil simply because it was done at the wrong moisture content, and when you are bringing up these hard clods which need further tillage to pulverize them down to a seed bed.
I'd like to show you two graphs that I've gleaned from this book called Building Soils for Better Crops, published by the Sustainable Agriculture Research and Extension Organization of the USDA. This first graph shows the effect of soil water content on soil hardness for two kinds of soil. The blue line is a compacted soil and the green line is a well aggregated soil. The 300 psi is the critical level for roots, so anything that's harder than 300 psi penetrometer reading is too hard for roots to penetrate. So as you can see, when the soil is more wet, the hardness is decreased simply because the soil has got the water in it to enable the particles to move and separate from one another. As the soil dries, the particles come sort of cemented together. As the soil water dries, it binds the soil particles, and a compacted soil will become much harder than a well aggregated soil, because a well aggregated soil maintains its pore space even when it's a bit dry. The next graph shows this for two soil types, a sand and a clay, where you've got the soil water content going from 0, which we would normally call permanent wilting point, up to saturation when the soil is fully wet and there's no air spaces in it. A sandy soil has a friable portion where you can till the soil easily at a higher moisture content than a clay soil. What happens with a clay soil is, as it dries, it goes from this sort of liquid state into this plastic state where it's like plasticine. You can mold it easily in your hands, and if you put a tillage implement in it when it's plastic, you just sort of slice it, you don't actually break it up. Then it gets to a point where it changes from being in a plastic state to a friable state, and at that point, in the friable state, it's ideal for tillage. As the soil water content decreases further and it dries out, the soil will become hard again, and you will not be able to till that without causing these big clods that we've seen in the pictures I've just shown you. In a sandy soil, when the soil becomes dry, it may not necessarily form clods because the sand particles are big and they don't form into these hard cloddy layers or blocks as much as a clay content, so that it just becomes loose. And I'm sure you're aware of this in a very sandy soil. When it's very dry, like at this time of year, in some places it's even very hard to walk through it because it's like walking through just this sifting sand and it's got no structure at all. So finding this friable state in your soil is critical for when you want to time your tillage to cause the least damage to your soil and to create the best environment for your planting operation.
Now if we compare what we've just seen to this field here, it's very close to where we've just been, but this was ripped some time ago. I can't tell you exact date, but I know it was done some months ago, and the moisture content was much better at that time. And you can see here, the ripping was done well, brought up very few clods. It's made some minor grooves in the soil, furrows, but these will be easily manageable when it comes to planting time. So you can see quite clearly the difference in the effect of tillage as a function of soil moisture content on the same kind of soil.